Everyone. How are you doing? Happy Valentine's Day to all of you. Actually, you're gonna have a good rest this weekend, and hopefully your weekend's long enough. I have Monday off, so probably enjoy that Monday off. I may not be free this weekend. Anyways, let's get to why we are here. And so I made actually three previous videos on JackWestin Practice Test 6. If you haven't seen them, take a look at them, especially the first video, because that highlights or emphasizes the strategies that I'm using to go through these passages. All right. So without talking too much, let's start with this. This passage number 2 for Jack Weston Practice Exam 5. All right. Again, highlights are your summary, they're your reference point. A good highlight to make this an open book test. Remember the red flags, the green flags when you're reading your questions, and always try to come up with some form of answer before you look at the answer choices, right? All right, so let's begin. Elimination reactions of alkyl halides may proceed through either the bimolecular E2 mechanism or the unimolecular E1 mechanism as depicted in this figure. So you can go through two pathways, right? That's what they're saying. And this is talking about elimination reaction of what? Alkyl halides. That's what they're talking about. Yes. Bimolecular. Again, you don't want to highlight, say, more than four things in a sentence. Unimolecular, right? All right. So these are the two reactions. This is the E2 elimination. You need a base to attack first. That attacks one of the protons that's on the adjacent carbon. And then what is left, the nucleophile that is left will attack the carbon that has the halide connected to it, right? And it forms an alkene. In E1, it is the opposite. The halide, the leaving group goes first before the double bond is formed. All right, three important parameters are considered when deciding whether an elimination reaction will proceed through E1 or E2. All right, so there are three important parameters we could probably talk about for a reaction to proceed through either of these pathways. Firstly, I like to highlight words like that. Firstly, secondly, because it helps me list them, right? The selection of the base is significant, such that strong bases typically favor E2, right? Whereas weaker bases can facilitate E1 reactions. So you need a strong base. Secondly, right? So we go to the next one. The solvent composition has a considerable influence. Polar protic solvents tend to promote the E1 pathway because they stabilize the carbocation intermediate. So polar protic solvents have what? E1 pathway. How do they do that? They stabilize the carbocation intermediate. I can highlight all of this, but I'll just highlight it. And then lastly, the structural configuration of the alkyl halides plays a role. So structural configuration is the last thing to think about. In instances involving primary alkyl halides, the absence of primary carbocations prevents the possibility of E1 mechanism, rendering only the E2 pathway viable. In other words, if there's an absence of a primary carbocation, in your intermediate or wherever the halide is, if it's going to form a secondary or a tertiary, it's probably going to favor the E2 pathway, right? So absence of primary carbocation is going to favor E2 pathway. I could highlight prevents the possibility of E1, but I'm just going to highlight these because I kind of know it meant okay, this favors E2 pathway. And then they gave us trans 1 chloro 2 methyl cyclohexane undergoes elimination reactions in either ethanol, reaction 1, or NAO, E, ET, sorry. I heard a noise and I was what was that? Ethanol, right? So that's reaction 2. Okay, so we have our strong base here. That means that's going to be our E2 reaction. In E1, there's no strong base. It's usually a weak acid, a weak base, something like that. So ethanol, yeah, But in E2, there has to be a strong base. So we have here, basically they're showing us E1 and E2 reactions, right? So now let's tackle the questions. Now that we have a good highlight, if we read the highlights, we pretty much summarize all the important information we need here. Again, anything you see, if you see it now for the first time, you want to highlight it. You want to highlight transition words that actually help you list it. So the way I'm saying this, firstly, secondly, and lastly, helps me easily find out the three important parameters that are considered when determining which pathway, a reaction is going to go through, right? So I really want to do a good job just highlighting the facts. A lot of the words that I've highlighted here, again, I keep saying this. Personally, I'll usually highlight just one word, but I know there are some who like to highlight a little bit more to help give them a clear understanding. So I'm helping that of people with this. But anyhow you highlight, just make sure your highlights can, when you read through your highlights, it's a summary of the passage, and there's not too much yellow. You don't want everything to be yellow, right? So if everything was yellow, it would be difficult for me to find out what I need to find out. All right, question number 6, so 6 to 9. The reason why only 3-methylhexene was formed in reaction 2 in figure 2 is because, so reaction 2. So our green cards here are 3-methylhexene and reaction 2. They're asking us why is it that in this reaction 2, we have no 1-methylhexene formed. So our red flag here is basically they're asking us, what is it about an E2 reaction that prevents 1-methylhexene from being formed, right? And I think if from your studies, whether it's Anki cards or your notes, one of the things that pops out to me I had to review E2, E1 before I even came here. I just looked at the topic, went to review it so that I can think through it with you, right? One of the things that stands out is that with the E2 reaction, they have to be anti-periplanar. In other words, they are moving in the opposite direction, but they are still in the same plane. The leaving group and the hydrogen that is going to be affected have to be in the same plane and opposite direction, right? And that's like one of your lowest energy states to allow the E2 reaction to move forward. If they are in the same direction, the steric hindrance. If they are in the same direction and same plane, the steric hindrance, right? So you always want them in opposite directions, and it makes it easier for the reaction to go through. So let's see our answers. That's what I remember, so I'm going to use that to try and figure out what the answer is. A says, in the anti-periplanar orientation, sp3 hybridized orbitals of CH and CCl bonds are on the same plane. That's pretty much what I said, right? I'm going to leave this one. B says in the anti-periplanar orientation, the energy barrier is much higher than the syn orientation, which is a lie. In the syn orientation, they're in the same place, right? Same direction, so steric hindrance. In the periplanar orientation, the leaving group is too bulky, which causes steric hindrance. That's not true. When it comes to E2, what we know is that a requirement is it has to be anti-periplanar, right? In the periplanar, so from this, I can cancel out or eliminate C and D, right? Because those are talking about things that are not required for E2 to happen. And based on what we read, we know they have to be in the opposite directions, and that reduces energy, right? So energy barrier cannot be high. They are on the same plane. So this should be the answer. So let's check it and see. And yes, that is the answer, right? So this is a way you get your answer first so that when you're reading the options, you try to fit it into the answer you know. I reviewed this not too long ago, right? So maybe it's easier for me to remember some of the facts. But because I remember the facts, all I have to do is I have to find out answers that are connected to those facts, right? Let's go to the next question and see. So we have a compound here. What is the major product of the given compound undergoing E1 reaction? I'll be honest, I've forgotten how to name these compounds, but I see my alcohol group here. And it's pretty much the same as these. Looking at the orientation, looking at the carbon and where they are, the methyl group is on the carbon adjacent to the halide or the alcohol. So if it undergoes an E1 reaction, my leaving group is going to be the alcohol, right? let me annotate here. My leaving group is going to be this alcohol. If that goes out, I'm left with, and just for continuity's sake, I'll use a different color, right? I'm left with my, what's it called? And how do you even call this? Electrons that will form the double bond right here, right? So just by going through even what happened here, what the leaving group, Cl left, and whatever was left formed the double bond here, right? So the major product is going to look the same as the major product here. That is my answer. So let's see if that is right. Now that I have this, and when I scroll, it's going to go with the screen, just bear with me. Once that I have this, I know my double bond has to be with my methyl group. So C looks like the right answer. All the others don't look like it, right? So our solution, yes, C is right. So this was a little bit straightforward. They've given you the answer in the passage, right? So this is more of a green flag question. They're giving you the answer in the passage. All you have to recognize is that this alcohol group is the leaving group, right? All right. So let's move on to the next question, because today I'm not going to take too long. All right, I'm done with you. Question 8. Using reverse phase high pressure liquid chromatography. As I'm reading this, I didn't read anything about this in the passage. So I'm beginning to try to remember what is reverse phase high pressure liquid chromatography. Which of the following would be observed when separating the reactant and product? So yeah, separating both of them, not just one side of the equation, both of them, of reaction 1 that yielded less than 100%. Okay, so we go back to reaction 1. It yielded less than 100%, which means there was some reactant left, right? And so if there was some reactant left here, we have a mixture of these 3 compounds. So we want to see which one is going to what? Elute, I guess, first or last, because chromatography, for my knowledge, the ones with less mass elute first. Very polar substances will elute first, because in liquid chromatography, static phase is usually non-polar. So let's see from just these 2, am I able to for a question like this, the truth is I'll have to go through each of the answers. Now I've remembered what I can remember about chromatography. I'm just going through the answers to see if I find the answer, right? So the major product will elute first. The major product is 1-methylhexane. This is not the most polar, and it has the same size as 3-methylhexane, right? So what's to say that which one will you first? It's going to be difficult, right? But let's go on. The minor product will do first. I'm not canceling anything yet till I see something that I really like or I really don't like. The reactant will elute fast. If anything, the reactant is more polar than these 2. Remember, the polar elutes faster than the non-polar. And the smaller it is, the faster it will elute. Like, smaller the structure or the mass is, the faster it will elute, right? Okay, so I don't think that is right. The reactant will elute first. Okay, so basically we are comparing the reactant to the product, and we're asking ourselves which one is smaller, but more importantly, which one is polar? Because this is liquid chromatography. In liquid chromatography, you're thinking about polar, non-polar, right? The static phase is non-polar. So everything that is polar will elute first. So I'm going to say that based on that fact, my reactant will elute first. And let's just see. That's right. For this question, I had to really remember what liquid chromatography was. That's my red flag. My green flags were I had this reaction here in the passage. So I had to compare what I knew about liquid chromatography to what this reaction was showing me. And to be honest, the key here was just figuring out between all these compounds that they are showing us in reaction 1, which one is more polar than the rest, than the others, right? All right. So that's number 8 down. Number 9. Okay, which of the following is produced when trans 1-chloro-2-methyl cyclohexane has undergone an E2 elimination? All right, trans 1-chloro-2-methylhexane. Okay, so 1-chloro-2-methyl. It still looks like this, if I'm being honest. Like if chloro is the first carbon here, then that means this chloro is the first carbon, and that's my 2, right? So it still looks like it's the same compound they're asking about. So it's a green flag question for me because I can use what is on my screen to answer it. So it has undergone an E2 elimination reaction. So it's going to probably produce 3-methylhexene. Um, the question now is, which one is the right answer? So anything that says 1-methylhexene, cyclohexene is out. This is going to be 3-methylcyclohexene, right? That's going to pass. The question now is it an R or is it an S? Now, we start, our chiral carbon is this one, right? It has 4 different groups attached to it. Hydrogen is usually the last group. So you don't even think about that group. But looking at it, it's connected to a methyl group, so a carbon connected to a hydrogen, right? And it's connected to a carbon here that's connected to 1 carbon, and it's connected to a carbon down here that is connected to 2 carbons, right? So the carbon connected to 2 carbons takes priority. That's number 1. The second group is going to be the carbon that's connected to only 1 carbon. And then my last group is going to be the methyl. It's the carbon that is connected to other 3 other hydrogens, right? And usually once you write it like this, you just draw an arrow to follow 1, 2, 3. If it's going in that direction, then it's an R. If it was going in the opposite direction, that's counterclockwise, then it's an S, right? That's if I'm even remembering right. But I believe this is what it is, right? So now that being said, this question is more of a green flag. I have my carbon, my compound and everything. Red flag, I have to remember what a chiral carbon is. I have to remember R and S configurations, how to determine that. So now that I've got this, I know it's 3-methylcyclohexene. It's going to be R. So between these two, my answer will be C, right? So let's see if C is right. C is right. The question asks about the middle verse. I think they've listed some things here. Let's see. Okay, E2 elimination reaction, remember, is always anti-periplanal. You want it to be it's going to be either in the axial or equatorial positions, but you want it axial because you want it in the opposite direction to reduce steric hindrance. And then given that the starting compound is the most favored product, it's going to be a methylcyclohexene, nice, right? Okay, right. 3-methylcyclohexene is the correct answer. I mean, they gave that as the passage. And then we just have to determine whether it's the R or the S. So hopefully you learned something from this. Let's meet again. I'll do a second video for JackWestin Practice Exam 5, and then we'll take it from there. All right. Have a good day. Stay blessed. Enjoy the weekend. If it's a long weekend, great. If it's not, still enjoy it. Rest up. It's all out. MIM for life, right?